Hello, this video will be to help you understand problem number 41 in chapter 7. It's the problem dealing with two eagles colliding towards each other. I don't think it says why they collide. Nope, they're just colliding with each other for no apparent reason. So the problem with this is they only tell you that they're perpendicular to each other, but they don't tell you if one is going up or down. It just says it's perpendicular. So you can basically choose either one you want. I chose to have the eagle like this going to the right, and the other eagle is going like that. Okay, and the one on the left I'm going to call MA. His mass or her mass is 4.3 kilograms and has an initial velocity of 7.8 meters per second. And then the one on the right I'm going to call MB. Has a mass of 5.6 kilograms. Velocity is initially 10.2 meters per second. And going to collide. I'm going to say going to the right and up is positive. The velocities are perpendicular to each other, meaning that the velocity of A will all be in one coordinate system, and the velocity of mass B would be in the other coordinate system. So they do not have momentum in the same coordinate system to begin with. Now the two eagles latch onto each other, so you're going to have a bigger mass here. The mass would be mass would be the two masses added together. Why is it doing that? Let's just keep it there. Now, the direction you draw will depend on the directions you had for your initial image. Okay, so I have an arrow going to the right, an image going up. So, it's weird. There you go. So that means that the arrow I draw over here has to be reasonable for those two. Okay, so it's going to go to the right and it's going to go up. So it's going to be like that. I don't know the exact angle. That's okay. But I know that the arrow is going to be something like that. And I don't know the velocity. That's what I'm trying to find. So this is a two-dimensional problem. So you're going to have to use the momentum equation from the diagram for two different directions. First one I'll have is M A V A initial in the x direction plus M B V B initial in the x direction equals MV in the x direction. And then do the same thing in the y. So you have MA VA initial in the y plus MB VB initial in the y, and then you have MV in the y. Okay? The mass B has no velocity in the x direction, so then you can just cancel all that out. And mass A has no velocity in the y direction, so you can cancel that out. So we can go ahead and isolate. So for Vx, you're going to have the final velocity in the x direction will equal MA VA initial in the x divided by the total mass. For Vy, you're going to have the mass B times VB initial in the y, all divided by the total mass. And you can see a pattern here. That's why I'm doing it together instead of doing them separately. So we can go ahead and put in the values. We have 4.3 kilograms for mass A. We have positive 7.8 meters per second, and divided that by 9.9 kilograms. Vx then equals a positive 3.388 meters per second. And Vy, you're going to have 5.6 kilograms plus 10.2 meters per second. And 9.9 kilograms. So Vy equals a positive 5.770 meters per second. I'm going to have to solve for the resultant velocity, so we're going to say V equals the square root Vx squared plus Vy squared. So you should have V equals the square root of a positive 3.388 meters per second squared plus positive 5.007 meters per second squared. You get a value of 6.69 meters per second. We're not done there because it's a two-dimensional problem, so we're going to figure out the angle. To do that, we're going to use tangent. Guess I should show you just in case. So going back here, let's do it down here. You had Vx and Vy. We just found V, but Vx was the positive 3.388 meters per second, and Vy was a positive 5.770 meters per second. So we can use tangent to figure out what this is. Okay, I want to know what that angle is. So I'm just going to have the tangent of theta equals Vy over Vx. So if I want to know what theta is, I do the inverse tangent, and I'd have Vy over Vx. So theta will be the inverse tangent of a positive 5.770 meters per second over a positive 3.388 meters per second. You'd have theta equals 59.58 degrees. So your final answer should be that the velocity equals 6.7 meters per second at 60 degrees above Eagle A's original heading. The heading basically means the direction of its motion. Okay, so if you wanted to use 60 degrees above north or north of west or anything like that, you would have to show north, west, east, south on the diagram and explain that. Okay, but otherwise you could just use the heading of the eagle for A or B, and it'd be fine. You just have to make sure you're careful and do that appropriately. Okay, so that's all there is for this one.